So we have to generate our first cutter now. If we look at this geometry that we have to cut up, and we take a look at our points as well, so I will template this, we can see that we will need a cut of the geometry that goes right along where the points are going, so in this direction here. Let's also maybe go ahead and let's grab this geometry, so I will Control C this geosurface node, and let's bring this over here with an object merge. Paste this here, and I will also just select these points and drop down a ray, and we want to ray these points to the geometry. So place this into our second input, and let's turn off show guide geometry and set the method to minimum distance. Alright, so if I were to template this geometry, we can see now that the points are sticking to the base of the geometry. Alright, so let's untemplate this. So we need to generate some cutter planes from these points somehow. So first we need to generate a trail from these points, and I will drop down a trail node. Let's preview this, and let's leave this as it is for now, and just increase the trail length until we get somewhere close to where we started. So just increase the trails here. Alright, so maybe let's see, these points stop at around frame, let's see, frame 50, and let's just make sure that we have enough trail length, and let's just set this to 60. Okay, and I will also freeze this at frame 60. So from here I will drop down a time shift and Control Shift click this value over here so we can disable the expression, and I'll just type here 60. Okay, so now we have a frozen geometry at frame 60, and from here we can drop down an add node, and in here we can go to polygons and we can select by group, and we can set this to be by attribute, and the attribute will be ID. Alright, so since we are generating a trail from our original 5 points, this trail will also inherit the ID of these points, and when we do the add operation, this will now create a primitive between each point that has the same ID. We can see that there's a small problem here where the geometry and the points kind of switch sides, so they are first rayed to the base of the geometry, and over here, because of the position where the point is, it starts to get rayed on the surface of the geometry. So we can simply fix this if I were to drop down a transform node after our PobNet, and we can either just make all of this ray from above or from below, and I will just drop down the translate Y value until we have these points nice and flat on the surface of the geometry, so rather the base. If I were to template this, we can see now that they are rayed nicely to the base. Okay, so from here these curves themselves can create our cutter geometry, but we will also need these curves as a separate object later down the line. So from here I will drop down a null, and I will set this to be curves. Okay, so this will also become important later on. Let's also maybe before this curves node add a resample and make sure we work with even points. So the main idea here is that from this curves node we can drop down a poly extrude node, and we just want to extrude these points on the y-axis. So we will go to turn this option on, so transform extruded front, and for transform space this should be set to global. And if I increase the Y value of this translate, we can see now that we are extruding straight up. Okay, and I can also preview my terrain if I template this, and we can see that we are generating our cutter planes now. The problem here is that these cutters should be completely intersecting our plane. So before this poly extrude node, I can just drop down a transform node, and I will move these curves first a little bit in the negative Y direction. So I will just decrease the Y value of this transform, and as I preview the extrude, we can see now that they are completely intersecting our terrain. On the same note of completely intersecting our terrain, these cutter planes should extend beyond our geometry that we want to cut, and also in the middle I want all of these beginning points of our cutting planes to share the same point, or rather the same location. So it would be easier to accomplish this if I were to just go to my curves node and work on these curves and then do this poly extrude business. Okay, so let's maybe untemplate this geometry for now. Go back to our curves, and what I want to do is, if I were to display the points, I want to have a group that contains all of the first points of these primitives and a group that contains all of the end points of these primitives. And we can do this if we iterate through each line primitive independently. So from the curves node, I want to drop down a for each connected piece, okay, and place this here. And this will create an automatic node for us, that's a connectivity node. And what this essentially will do is look at all of the primitives, and if they are not connected, it will assign an attribute called class to each of them. So when we go to our for each node, and if I were to turn on single pass, we can see that we can iterate through all of them separately by using this piece attribute that's called class. So if I were to look at just one of these lines and turn on my point display and also my point number, we can see that these numbers have increasing values along the length of the curve. And so what I want to do now is I will drop down an attribute wrangle, and for example to select this endpoint, we can see that this starts as 0, and this should be the same for all of the primitives. So if I were to go to my single pass and choose another primitive, the end point here should be 0. Alright, so this is the same for all of these. Okay, and if I were to drop down an attribute wrangle here, I can simply put this this number with the 0 inside a group, and we can do this very easily if I just say that if, and in parentheses, ptnum equals 0. So if your point number is 0, then you will be inside a group that's called end, and I will set this to 1. So this attribute wrangle will iterate over the points, and like we said, if your point number is 0, you will now place it into a group that's called end. So if I were to go to my information for this attribute wrangle, we can see now that we create a point group that's called end over here that contains 1 point. And we can assign group to points or primitives inside a wrangle with this syntax over here that says @group_. Okay, so whatever name we place here after our @group_, this will now be the name of the group that we create. And to place the points that meet the condition inside the group, we'll just set this value to 1. So on that note, we want to create a group again for the last point in our primitive. And to get the value of this point, we can grab the total number of points and subtract 1 from this. So because our point count starts at 0, this will mean that the total number of points for this primitive will be 159. So to get this point here at the end, we have to subtract 1 from this. So here we can say that if, in parentheses, your point number equals the number of points, so num_pt minus 1, so this will now bring me my last point, then I will say that group start equals 1. Alright, so if I go to my for each and disable single pass, we should have now a group that has all of our endpoints and a group that has all of our start points. So from here, before we poly extrude, let's drop down another transform node and let's run this over a group. So now we can set the start group, and if I were to turn off these displays and increase the uniform scale, we can see that we are only affecting the start group. So these points here right at the end of our primitives, as you can see. So if I were to set the uniform scale at 1, we can see now that we sort of bunch all of these points, these start points, into a single point. And maybe we can also translate these a little bit below, so negative 0.2, just so they're consistent with our curves. And I can rename this to move start PTs, move start points. Let's make some room, and again we will do sort of the same thing, and we want to move and PTs with this transform, with the second transform, and I will set the group to be end. And from here we can also transform these, and we can see that we can sort of extend the curves this way as well. Let's also fuse all of these points here that are bunched in the middle. So I'll drop down a fuse node, and we should see that our point will be decreased as I turn this on. So we can see that from 755 we went to 751. So this means all of these points here that are right in the center are being fused together. And so now when I do this transform and the poly extrude, we have our cutter planes that originate right in the center and they extend outwards of the geometry. So if I were to preview my geosurface, let's template this, we can see that this now extends further out. And we actually don't really need to extend this much further out. So with our move and transform node, we can just scale this down a bit. So we just have to make sure that they extend outside of the surface. So let's rename this to, let's drop down a null from our poly extrude, and this can become our cutter init.